So M1, U1. There is another mass M2 going with U2 velocity. And the same line, U1 is greater than U2, so they collide. When they collide, there's a lot of energy loss. Okay, there's sound energy, there is heat energy, big time collision happens. Okay, then the bodies get distorted. So in that case, is the initial momentum P initial, let it be, is equal to the final momentum, like after collision, say the bodies are going, there's a lot of distortion and all, there's separation, the velocities will not be too different, V1 and V2, but might be equal also. Maybe V2 is little more than V1. So what do you think? The initial momentum and final momentum will be same or different? Lot of energy loss. Yeah, somebody speak. Prerequisite is collisions, you should know. Then only collision in 2D. Uh-huh. Yes, guys. Come on.
There will be same.
Yeah, who is that?
Anbu.
Yeah, why?
Uh, Momentum is conserved.
Yeah. Even if energy is not conserved, momentum is conserved. Why? Because of several reasons. So we don't have to get into all those reasons right now. One of it I can just say is, one way of putting it is, the center of mass of a assumed mass of m1 plus m2 was going with a certain velocity, say u, which is given by m1 u1 plus m2 u2 divided by m1 plus m2, and that center of mass will remain going at the same velocity, same u, because there was no external force. A collision among the bodies constitutes of internal forces. Okay, is one way of putting it. The other way of putting it is, one gave a certain impulse to the forward body, the same impulse you got it back on the reverse body, and the impulse is change of momentum. So one momentum got increased, the other guy's momentum got decreased, but the net momentum remains same, and the impulse given is equal to impulse received because of third law of motion, that action has equal and opposite reaction. So there are many ways of putting it, but the basic point is your initial momentum and final momentum remain same unless until there was an external force. Somebody is kicking from outside. After the collision, somebody is doing some work, putting some force or some impact from outside. Then only the momentum change. Due to their own collisions, the momentum is not going to change. So is that clear, everybody? Meaning to say, you can use this formula m1 u1 plus m2 u2, which literally is the velocity of the center of mass if I divide by m1 plus m2, is equal to m1 v1 plus m2 velocity, center of mass ka velocity, if I divide with m1 plus m2, it literally says that the center of mass velocity has not changed. So that you can use all the time if there is no external force. Is that clear, guys? On top of it, this is always to be used. So equation number one. On top of it, luck by chance. If it was an elastic collision, then you can conserve energy, right? Right? If elastic collision, then you are also permitted to use what? Half m1 u1 square plus half m2 u2 square must be equal to half m1 v1 square plus half m2 v2 square. I'm just writing it down. I hope everybody knows about it, right? Initial kinetic energy is final kinetic energy. But then using this line is such a pain because it has got squares and you have to get into quadratic that we have a simpler format. elastic collision. The format is quite simple. It is done this way that you put your M2s on the same side, M1s on the other side, and you'll get a half common all over, M1 common, U1 minus V1 the whole square is equal to U2 minus, sorry, V2 minus U2 the whole square. So when you do that A square minus B square formula, then it will ultimately lead to a simpler question equation when we solve it with the first equation, and that equation is that we avoid using this avoid, because this equation combined with this equation, I hope you know that, guys, whatever I was saying. Do you know that, or shall I try write very fast? Yes, guys.
Yes.
Yeah. So we can avoid using this and we can substitute a better equation, which is, instead of this being my equation number 2, my equation number 2 would be, and what is the other equation? What is the other equation? When energy is conserved, yes, guys, what's the other equation? When energy is conserved, how do you solve questions, man, if you don't know the equation? The equation is velocity of approach, that how fast it was closing up. So U1 was faster than U2. U1 minus U2 is equal to how fast that's this time V2 is faster than V1. Okay. So we use this as our equation number 2. If elastic collision, right? Is that clear? Equation number 1 and 2 simultaneously, if you solve, there are two variables like V2 and V1, and you get all the answers. Any doubt about this? That's your linear collision. Now, if it was inelastic collision, then too, fortunately, we have an equation which is somewhat related to what we have written. The velocity of separation V2 minus V1 is equal to coefficient of restitution E times velocity of approach, right? So for elastic collision, E is equal to 1. Otherwise, you have an equation valid for inelastic collisions also, provided there's some good guy who has given you the coefficient of restitution. Restitution means the body is getting deformed at the point of collision, at the time of collision, how much it reforms. If it reforms fully, then it is elastic. If it remains deformed a bit and doesn't bounce back fully, then it is not fully elastic. If the reformation is zero, then it is totally inelastic, and the bodies, after deforming, they stick together and go because they are not bouncing off. Is that clear? So this becomes a even better equation number 2 to solve, which is valid for all cases, elastic, inelastic, and everything. Is that clear, guys? Is that clear? Is that
Yes,
clear?
sir. Yes, sir.
Yeah. So, so,
Sir,
so eventually this equation goes for a toss and we would never be using that equation. Okay. Okay. In school exam, this equation number 2, what I written below, comes a lot like proof that the velocity of separation will be equal to velocity of approach and all. Okay. That's like one line job which I was speaking out and I asked, do you get that or not? And somebody said you get that, then that's it. Okay. So it is simply A as B square formula. So you have just the kinetic energy equation. You have to write the M1 on one side, M2 on the other side. And similarly, equation number 1, you'll write your M1s on one side and M2s on the other side, and you divide off the two equations. Your U1 minus V1 gets cancelled, and on the other hand, your V2 minus U2 gets cancelled. Okay, so this is your linear the collision in one dimension. Okay. Now collision in two dimension, which is the topic for today. Right. So here, okay, one more thing, linear collision in one dimension. We can just add one more thing. So I will shift the box a bit up so that I can add. If fortunately M1 is equal to M2 and it was an elastic collision, then the calculations are quite simple. Your U1, body 1 was going with U1, body 2 was going, both are M only. The other body was going with U2. After collision, the body 1 starts going with U2, which is the slower body, and body 2 starts going with U1, which is the larger velocity, greater velocity. The velocities get exchanged. Is that clear? Is that clear? Because from the equation number 1, you can easily see that M and M are same. Then we have one equation as U1 plus U2 is equal to V1 plus V2 from equation number 1. And from equation number 2, you have U1 minus U2 is equal to V2 minus V1. Okay. So if you add the two equations, you'll get it whatever I have said. Is that clear? Is that clear? Okay. Now, just 1 second, guys. Just 1 second. Okay, so I hope you would have Googled it earlier, but I'm just going to show you anyways. Enjoy some music, shall we? So can you guys see that when one ball strikes a ball which is not moving at all, the first ball will not move at all because the velocities get exchanged and the other ball is going to move. So this guy, I don't know whether you can see the cursor or not. Do you see a cursor on the screen? No? Yes?
No, sir.
Are you seeing the
No,
video?
sir.
Yes, sir. But we cannot
Okay,
see
so
cursor.
okay, so the hazy ball is going to go and strike the middle ball. So hazy ball is going to stop. The middle ball is going to achieve the velocity of the hazy ball. Then the hazy ball So the middle ball, which has achieved the velocity, is going to strike the next ball, which you won't be able to notice, and it will stop. So it will look like the middle ball is always not moving because they are so close. And the last ball is going to go with the velocity of the first hazy ball. I think enough for now, and I hope you catch the point. By the way, I didn't know this video existed. I just wrote, and there were few which came. Luck by chance, it was one with some music. So, where was I? Collision in 2D, right? So now this is a certain sphere which is going to go and collide with another sphere, which unfortunately is not in line. Okay, suppose it is like this, or yeah, that should be okay. And it goes and collides. Are you getting the situation, guys? I'm so sorry, my throat is really bad. It goes and tuck, it collides over here. Is that clear? So how to deal with this situation? So the point is, this situation is also like your 1D collision, nothing too special about it. What you have to see is at the point of contact, when it is going to hit it, okay, that time is the only important time. And that time is the only time the pink ball is going to realize that somebody is going and hitting it. So I'll just redraw the orange ball. It goes and hits it over here, right? Suppose the simplest of the cases, pink ball was not having any velocity. So what do you think, which way the pink ball will go? Anybody? Anybody? Which way the pink ball go? What happened to the pink ball? It received an impact, right? In what direction?
Northeast.
Yeah, it received an impact in this direction, right? Right, guys? And Newton's law is that the orange ball would have received an impact in that direction, right? Since I made spherical bodies, those normals would be crossing the center, right? I can just join the centers, say that they have received forces in the direction of, this is the direction of collision, right? Is that clear, guys? Is that clear? Now, this orange ball, had there been another situation that it was coming from here and it was going and hitting the pink ball. Are you understanding? It was coming from here and going and hitting the pink ball. The ping ball doesn't know a difference between the two situations. It doesn't know from where it was coming. It doesn't know it was coming from here or it was coming from there. It is hitting it like this. Are you getting the point? So this question is as good as a simple 1D question that the ball is coming and hitting like this. Is that clear? Is that clear, guys? Is that clear what I'm saying?
Yes, sir.
Yes, sir.
Okay. So okay, so what we say is we see that this ball, I hope you see the cursor right now. You are able to see the cursor. This ball has got a velocity in the hitting direction. This is how it was going and hitting, and hence we have to make two components. But there is another velocity which I would say is in the not hitting direction. Okay, guys, is that clear, guys? So this ball is acting like two balls. Okay, what kind of two balls? I'll show you. Or let me try to show it this way. One which is coming and hitting it. My orange arrows are not very straight, so pardon me. One which is coming and hitting it, and one which is not hitting, sliding by. Okay, so I call this one as sliding by component. Okay, it is not hitting at all. It is as if there was a ball coming from uh, uh, so many of them now. It is as if a ball was coming from this side and just went by. Okay, that's a sliding by component. Can you imagine that? Is that clear? Is that clear?
Yes, sir.
Yeah.
Yes,
So
sir.
this, yeah. So this leaves us to a situation something like this. It has become too many spheres, and I'll be little clumsy drawing all of them in the right position. So it leaves us with a situation as good as that there is a hitting component and there is a sliding by component. If somehow we are able to manage to get the angle theta, which we should be able to manage, if we are able to manage to get the angle theta, why? Because they will provide us the dimension. What is the size of this sphere? What is the size of that sphere? And what is the line in which one was going? So we should be able to manage this angle theta. Okay, but by joining the centers of the two, as I told you, okay, we should be able to manage this angle theta. So what do we get? We get if the velocity of the orange ball was say u, then this is how much? U cos theta, and this is how much? U sin theta. Now my physics brain should say that the question is simply about a sphere coming with u cos theta from this side and hitting it. This sphere came with u cos theta, and it came with u cos theta and it is hitting it. Is that clear, guys? Is that clear? It's a one dimension question of this sphere coming with u cos theta and hitting it. So I will just draw a bit below. Here, this sphere was coming with a physics. For a physics guy, it is as good as a sphere coming from here with lines something very straight. So I hope you get it. Okay, u cos theta. It is simply a one dimension question. Okay. So can you just write the equations for this one dimension question? Say this mass was m1, this mass is m2, This velocity, for the simplicity sake, is initially u is equal to 0. Okay, velocity of this is 0. So can you tell me what's the equation? What's the equation? Anybody? Anybody? Somebody?
Sir,
After some time, it will go up. The pink ball will go up. Why? Because it has been hit in that direction. The orange ball would have also gone somewhere after hitting. Okay, since there is less space, I'm just drawing it over here. Let me manage some more space. Yeah. What is the equation? What is the equation? Guys?
sir, yeah. M1
Yeah.
u cos theta equals to M1 V1 plus M2 V2, and then u cos theta equals V2 minus V1 if it's elastic.
E is given to you. Let us do a proper one. E is given to you. So is he right, people?
Then
Is he right?
Yes, sir.
Hmm? Yeah, where was I writing the screen? Lost all my screens. Yeah. So the equation would be what? It's going with M1 is going with u cos theta 1. M2 was having zero velocity. Later on, perhaps M1 is going with a V1. I'll call it as a V1x, and this is my x direction, and this is my y direction. This is my y direction. So, and this is going with V2x. So one of my equation is M1 u cos theta plus M2 into 0 is equal to M1 V1x plus M2 V2x, where the unknowns are V1x and V2x. Is that clear? So what is the other thing you write to solve V1x and V2x? That's the equation number 2, which we discussed earlier. I mean, this one is the equation number 1. The equation number 2 would be what? Velocity of approach. Velocity of separation is E times velocity of approach. Okay, so what's the velocity of separation? Anybody? V2x minus V1x. Okay. Velocity of separation and approach is necessarily written in the line of the collision. If you don't write this equation number 2 in the line of the collision, this green line, where it is impacting and receiving the uh, and exchanging the impulse, if you don't write E equation in that line, then your equations will be wrong. You are not allowed to write in any other line. Whereas this equation number 1, conservation of momentum, you can write in any which line you please. So it is best to write in the line of collision because it is quite convenient to write, but you could have written in any which line you please. Is that clear? But this equation has a constraint, okay, and rightly so, because it is about approach and velocity of separation and approach depending on the restitution. So it is only written in the line of the impact. Is that amply clear, guys? So what is this? What is the velocity of approach? Anybody?
U cos theta.
Yeah, u cos theta minus 0, which is u cos theta. So these are two equations, and obviously you'll get a proper solution out of it because there are two linear equations, two variables. What are the two variables? These are your two variables. This one, this one are the two variables, and you have two equations. You get a solution. So is this the complete answer? No, it is not the complete answer. It is the complete answer for the pink body because it is only going in that direction, but it is not complete answer for the orange body. It tells that the orange body will be going with V1 in this direction, but the orange body was initially going with u sine theta, and that component did not collide anywhere. It just was sliding by. So that component always remains wherever it is, u sine theta, and doesn't go anywhere. So that component still remains. How much is that? U sine theta. So the point is, you get your V1x by some calculation. Your V1y will remain what was your U1y, which was nothing but U sine theta. Is this point clear, guys? You had a U1x, which was U cos theta, and you had a U1y, which was U sine theta. U1x became, it changed to V1x, it reduced, U1x was say this long, then it became less because it got an impact backwards, but U1y remained whatever it was. Is that clear? So your ultimate answer is, your ultimate answer would be, now vector addition of the two, so you'll get that, okay, your velocity is going somewhere over there. Is that clear? Is that clear? Is that clear? And how much will that be?
Yes, sir.
Under root of u1x square plus u1y, which is nothing but u sine theta whole square. Right? So that's your answer. How do you get the direction? You get the direction by doing a tan inverse of the y by x, and you get this angle. But this angle was not the angle with the horizontal, and you have to report the angle. Say this angle is the angle with, I call it as alpha. If you have to report the angle with the horizontal, I'll change the color a bit. Which color shall I show? If you have to do it with the horizontal, then it was theta. So much was theta. So it comes as alpha minus theta below the horizontal. Okay. So you have a bit of hassle in reporting that direction is going if you they want to report it with the horizontal. Okay. Is it clear? Is it clear? Shall we do a problem on this and see how much of our understanding is there for such a question? And that will end the session today. If you want any one part to be repeated, I'll repeat it. And before you ask, I'll repeat it as such. If there is a 2D collision going to happen, then first is geometrically you will draw how it is and get the line of contact, line of impact. Geometrically you'll draw the position where it has collided and get the line of impact and the initial line of travel. Okay. So once you get the line of impact from the initial line of travel and figure out the theta, then you break the components into hitting component and sliding by component. Okay, this is what is going to hit and this is what is going to be unchanged. Okay, is that clear? Is that clear? You do your linear momentum conservation with your hitting component. Okay, now by the way, if this guy was also traveling with some velocity, say u2, then you will again break it into the line of impact and the sliding by. U2x and U1x is going to undergo the equation of m1u1x plus m2u2x is equal to m1v1x plus m2v2x, and you will write your E wala equation. What is the E wala equation? v2x minus v1x is equal to E times u1x. Mind you, u1 was greater than u2, and after collision v2 is greater, minus u2x. You'll write this and you figure out these two values. Okay, that is not the end of the story. That is the new velocities you have figured out. Okay, that means after collision, I'm just drawing them. This is the thing after collision. So you have found out the new velocities in the x direction, but their old velocities in the y direction remains whatever they were, right? And you will do a this square plus this square to get the net velocity. You'll do a this square plus that square to get the net velocity. Is that clear, guys? The process? Is that clear? Shall we do a question? Shall we do a question? Or you want me to
Yes.
repeat anything? If you want me to repeat anything, ask me. We have only 13 minutes. Yeah, people. Okay, I'll give the question. If you have something to ask, please ask while the others are doing it. So there is a carom board striker, which is generally larger and having more mass. So I'll go by that. And somebody is playing a cute cut shot. You know what is a cut shot? When you don't put a head-on collision and you try to make the other thing go at an angle. So let me draw a line first so that I can properly refer. And somebody is playing a cut shot. Is that clear, guys? The size of the coin is r is the radius. This radius is r. The other guy's radius is 2r, which we can easily see, right? I've drawn that way. The diameter of one is the radius of the other thing. And let us put this mass as orange mass as m, and this mass as if it is the same material, how much will it be, guys? If it's the same material and thickness is same and all. So the area is how many times? 4 times, right? 4m it will be, right, guys?
Yes,
Right?
sir.
So it's not the same material. It is some plastic, this and that. Say 3m डाल देते हैं इसको. Okay. 3m. Okay. And the initial velocity of the striker was u. Okay. Shall I give you some values or what? Yeah. This u is equal to say 4 meter per second. That's very slow. No? I just hit it quite fast. 10 meter per second. Okay. So now tell me, What is the ultimate velocity of the orange thing? I'm giving you an easy question. Orange was not moving. Or shall I give you a question with orange moving? What do you want? There's no time. So orange was not moving. Okay. Is that okay? Is that okay?
Yes, sir.
But if I give you with some movement, no, it will like totally nail all the concept over here. So I'm just wondering what I should give. I'll give you with orange moving as homework. Orange not moving you do, because I've done two things today. Not moving and then moving. Orange not moving. Get the answer. Okay. Even if I've given R and 2R, M and 3M, things will cancel and you'll get a numerical answer. It will not have M's in it. It will not have R's in it. Okay. Now, people who had doubt in the earlier concept may feel free to ask. First thing is redraw at the point of collision, join their centers, and figure out through geometry at what angle it is striking. When I say figure out the angle, you are mostly figuring out the sine theta of the angle and the cos theta of the angle by making a good right angle triangle for yourself. Is that clear? If you have no doubt, you should get an answer. Otherwise, you should have a doubt. Somebody is saying something. No, I can't hear actually. Can you hear me, guys? Hello.
Yes, sir.
I think something has gone wrong. 1 second. Because I could see Anika Chatterjee chattering, but I can't hear. Hello. Oh, really? I can't hear. Why, man? Anybody else say something? Somebody else? Are you saying something? Write in the chat box. If you're saying if you're
Sir,
speaking out. Yeah, I could see Anbu. See, could not hear. That means something has gone
sir,
wrong.
did you give the value of
You guys
R?
can hear me, right?
Yes, sir.
Oh, good.
So could you repeat the masses again? It was
Yeah, change the output to the internal speaker. I wonder why it happened that way. Can you still hear me?
Yes,
yes,
sir.
sir.
Yeah, okay. Put you on speaker. Bluetooth is
Sir, can
not.
you show us the values of the in the question again?
Is it not there on the screen?
No, sir, we can't
No, sir.
No, sir.
see it.
Okay. Okay.
Yes, sir. Thank you.
And I said you should get a numerical answer. Okay.
Sir, is it
There won't be
elastic?
any R's. Won't be any M's. Yeah.
Sir, is it
What?
elastic?
Oh, let us put some E. Thank you for asking. E is equal to how much you want? Tell me.
3/4.
Huh? Speak.
So 3/4.
3/4. Okay, 3/4. E is equal to 3/4 on demand. Oh, the speaker went off. I was saying that there's no time left. Now, shall I do or are you doing? Shall I wait or shall I show? Are you doing, guys? Anybody doing? Hello. Either ask me to wait or ask me to do. What is it?
Sir, please do it.
Okay. At least the first step, people, have you figured out the angle theta? If not, I'm just doing it here for you guys because if you have not figured out that, rest everything will go wrong. So from center to center, you join. How much will that length be? How much will that length be? The black line I've drawn, how much will that length be?
3R.
3R, 2R plus R, right? That's a 3R. Okay, so that's the line of collision with the D line. So we'll try to make a 90-degree triangle. So it is right over there that I just dropped a perpendicular from here. And I got my 90-degree triangle, right? Right? I got my angle theta at which it is colliding, right? What is that angle theta? To be described in terms of sine theta and cos theta. So sine theta is how much?
1/3.
That is R divided by 3R because this length is R, right? R divided by 3R. So how much is that? 1/3. What is cos theta? Obviously, you can do the sine square theta plus cos square theta is equal to 1, or you can do the Pythagoras theorem over here. It is a 3 square minus 1 square, which is the 8 square. So under root of 8 is 2 root 2. So 2 root 2 divided by 3. In and out. In and out.
No, sir.
What's the next job? The next job is to consider the ball was coming straight from here, right? The purple ball was coming straight from here somewhere and hitting it, okay, somewhat like this. It was coming like this, okay, and hitting it. So what was that velocity? So we'll try to break this velocity in that direction, right? Right? Then once you have broken in the hitting direction, we have to have a not hitting direction, non-hitting direction. Okay? So what are those? The hitting one is u cos theta. How much is that? (20 root 3) sorry, root 2 by 3. Is that clear? Is that clear? There's a non-hitting one, which is u sin theta. How much is that? 10 by 3. Is that clear? So now what equation you write? Anybody speak out the equation? Somebody? What equation do you write? What equation do you write?
Momentum and then
Yeah, so what is it?
velocity.
Speak out the equation. What's the
3m into
equation?
3m into 20 root 2 by 3
3m into 20 root 2 by 3
equals
zero
equals
or
m
0, yeah, is equal to, yeah,
equals to mv2x minus 3m v1x,
minus. Why do you put a minus?
because it's okay plus, I think.
Yeah, maybe it is going the same way. These are variables. If it comes as negative value, well and good. Okay. Is the point? Maybe the purple striker rebounds, you are thinking, maybe. So yes, it will come as a negative value. Okay. And perhaps it is more heavier, so it may keep going in that direction, right?
Yes,
And
sir.
for the other one, m into v2x, right? That is one equation, and we have only two variables, v1x and v2x. What is the other equation?
20 root 2 by 3.
Yeah, tell me completely, then I'll write.
To 20 root 2 by 3 equals 3 by 4 into v2x minus v1x.
Wrong, absolutely. Velocity of separation is always lower than the velocity of approach. So somebody correct what he has said.
20 root 2 by 3 into 3 by 4 is equal
Yeah.
to 2x minus v1x.
Yeah, v2x minus v1x is equal to, this is the velocity of separation, is equal to e times, which is 3 by 4 times the velocity of approach, which was 20 root 2 by 3. I hope you are seeing that everything is being done with this 20 root 2 by 3, and everything we are just considering it as a collision in 1D. Is that clear? Just to get the answers and then get cancelled. So if you add equation number 1 with equation number 2, your v1x gets cancelled, right? And what do you get? You get a 2 v2x is equal to 20 root 2. On the top one, it is a 20 root 2. 3 and 3 is getting cancelled, right? And from the bottom
Sir, in
of
the first equation, it's 3v1x.
which one?
In the first equation, it's 3v1x.
Oh, 3v1x. I'm so sorry. So we'll make it 3 times over here. Okay. Multiply it 3 times and add it up. Thanks a lot. Who is that?
Sir, Hasini.
Yeah. You saved me from crying. Okay. So, yeah, what was I saying? 3v1x. So 3 and 3 gets cancelled. So you have 3v2 plus v2, which is a 4v2x is equal to, from the top you have got a 20 root 2, and from the bottom you have got a 15 root 2. So 20 plus 15 is a 35 root 2. Is that okay, guys?
Yes, sir.
So you got your v2x value. v2x is equal to 35
35 root 2 by 5.
4 into root 2. Is that clear, guys?
Yes, sir.
Done, but that is not the velocity of, I mean, this is the complete velocity of the orange ball. We got one thing sorted. The orange ball is going with it is going with your whatever we calculated, 35 by 4 root 2. Okay. Now what is the purple ball going with? Somebody just calculate and tell me. That's the
15 by 2.
last,
15 by 2 root 2.
full velocity, everything like end to end, last result. Yes, guys. So I think she told me the V1x value, but that is not the right result. Last result. This is the right value what she said, I think. Okay. What is V1x? V1x will be equal to V2x minus, how much is that? 5 root 2, right? Right? So V2x minus 5 root 2, that means 20 by 4. So 35 minus 20 is 15. 15 by 4 root 2. Is that what he said, right? I think, huh? That's in V1x. Is it the end result? Is it the end result? No, this is the velocity with which your purple ball is going, the striker is going in the x direction. What is the y direction?
10 by 3.
What is the y direction, guys?
10 by 3.
It's 10 by 3, right? So what's the ultimate answer?
So I'm getting
12.8.
What? So V1x square. So V1x square will be like 15 square into 2 by 4 square plus 10 square by 3 square. Is that clear, guys? Is that clear? That's the ultimate answer. Your angle will be equal to, alpha will be equal to tan inverse of, or tan alpha will be equal to, where I'll say alpha is this. This is your alpha. Yeah. So anybody, how much is alpha? It is 10 by 3 divided by 15 root 2 by 4. Okay, that's your alpha. How much is the angle with which the ball is going with the horizontal? That's the red angle. How much is the red angle? Red angle is alpha minus theta. Okay. You can go to any level of like complication with respect to trigonometry, that what they are asking, but generally a physics question would not have too much of math in it, and things will be pretty obvious. Whatever is being asked, we'll do that way. Is that clear, guys? Is that clear? Is that
Yes,
clear?
sir.
Okay, I just want to end it with just one note, which is, listen very carefully. This body was going forward with u, which is equal to 10. I say after striking, let me make this body somewhere over here so that I can have some diagram, proper diagram. After striking, so this is my line of, this is after dash, it is after striking. This orange sphere has gone somewhere over there. Orange sphere is somewhere over here. And we are calculating the velocity to, which was v2x, which we got it correctly, okay, in one go. And after striking, my the purple sphere is going, it was straight. Where will it go? It will have an impact this way. So where will it go? It will go below the line, right? It is going somewhere over here. Okay, my purple sphere going. Is that clear? After striking, it is going down the line. Okay, so let me make it more proper. Now, if I say this velocity with the horizontal was say theta1, and this velocity is theta2, then I'm going to write some equations which are absolutely right, but it is pretty much impossible to solve. Okay, which is 3m into full u, horizontal direction I'm writing. 3m into full u plus orange was 0 is equal to, after collision, it is 3m into, suppose this is v1, 3m into v1 cos theta 1 plus m for the orange body, m into v2 cos theta 2 is in my horizontal direction. Absolutely right. No doubt about it. That this equation is right or wrong, absolutely right. You can conserve in any line. Then writing the vertical line, initially this vertical movement was 0, that vertical movement was again 0. 0 plus 0 is equal to, finally orange is going up and purple is going down. So I'll write purple first. I'll write purple 3m minus 3m into v1 sine theta 1 plus m into v2 sine theta 2. Absolutely right equation. But then I hope you can see that you have cos theta 1, sine theta 1, cos theta 2, sine theta 2. Technically, it is like theta 1 and theta 2 are two variables, but just eliminating, making a sine into a cos and solving is too much. Okay. And herein, obviously, you'll again have to write the E wala equation, and the E wala equation, the one equation which was having E in it, you have no option. You'll have to break the velocities and you'll have to write E into how much we got? 20 root 2, what was it? What was the U cos theta?
20 root.
Root 2 by, what was it, man? This was the cos theta, no? 2 root 2 and into 2 root 2 by 3. No,
Yes.
no. Yes? Huh? Okay. Okay.
Yes.
So we will have to do that, what we did earlier. We'll have to do that because line of collision equation can be written only that way. And then this fancy v2x minus v1x will come, okay, which is nowhere. This v1 and v2 is not related to the upper v1 and v2, okay. So as such, it is a big problem. So you'll have to get your theta angle from this theta. This theta 2 is fortunately this theta. The cos theta was equal to 2 root 2 by 3, and this theta 2 is fortunately the same theta. Why? Because orange was not having any motion earlier, so it will go in the angle of the hit. Okay, well and good. But theta 1 is not. Okay, so this becomes really messed up kind of. All equations are right. All equations are right, but solving is a big mess. So are you getting the point what I'm trying to say? When you have to solve a 2D equation, you solve in the line of impact. Is that clear, guys? So bye-bye those who have understood. Those who have not understood, may stay back and ask some questions. Rest. Enjoy the rest of your day. Have your dinner if you have not. Bye-bye.
Thanks, sir.